Good morning, students. So, welcome to the online classes that are conducted by Global SHAHEEN College, Tumakuru. And I am going to handle chemistry subject. I think many of you are familiar with me in first year. So, in second year chemistry subject, the topics that you have to study, they can be classified into three branches. That is, physical chemistry topics, inorganic chemistry topics, and organic chemistry topics. So, in today's class, I'll start with physical chemistry topics. Okay, so the first chapter in physical chemistry, it is solid state. Okay, you know that chemistry subject deals with study of matter, and matter exists in three different states: solids, liquids, and gases. In first year, you have studied about that is gaseous state and liquid state of matter. So in second year, we will be studying about another important state of matter, which is solid state. See, we know that in our daily life, we come across with many substances. Some of them are solids, some of them are liquids, and some of them are gases. But most of the substances we come across in our day-to-day life, they are solids. And solids are required in our daily life for various applications. And in order to use different types of solids, properties of solids must be different. And the properties of solids, they mainly depend on the constituent particles, the arrangement of constituent particles. See, if question is asked, why matter exists in three different states? The basic reason we can say is difference in the arrangement of particles. So in first year, you have studied about, that is, arrangement of constituent particles in three states of matter. See, in order to understand about the properties of matter, it is very important to know about the arrangement of constituent particles, that is structure. So without understanding the structure of solids, it is not possible to prepare the solids which are having desired properties. Say for example, in today's life, we are using solid substances which are superconductors at high temperature, and similarly we are using many solid substances which are having precise magnetic properties. Similarly, we are using biodegradable polymers for packaging, and similarly biocompliant surgical implants. I think you might have heard about pacemaker. ಅದನ್ನ ಹಾರ್ಟ್ಗೆ ಇಂಪ್ಲಾಂಟ್ ಮಾಡ್ತಾರೆ, ಪೇಸ್ಮೇಕರ್ ಅಂತ. ಸೊ ಸರ್ಜಿಕಲ್ ಇಂಪ್ಲಾಂಟ್ಸ್ ಅನ್ನ ಪ್ರಿಪೇರ್ ಮಾಡೋದಕ್ಕೆ ನಮಗೆ ಏನು ಪ್ರಾಪರ್ಟೀಸ್ ಅನ್ನ ಚೇಂಜಸ್ ಮಾಡಬೇಕಾಗುತ್ತೆ ಸಾಲಿಡ್ಸು. ಸೊ ಆ ಪ್ರಾಪರ್ಟೀಸ್ ಅನ್ನ ಚೇಂಜಸ್ ಮಾಡಬೇಕು ಅಂದರೆ ವಿ ಮಸ್ಟ್ ನೋ ಅಬೌಟ್ ದಿ ಸ್ಟ್ರಕ್ಚರ್ ಆಫ್ ಇಟ್ ಇಸ್ matter. So correlation between structure and properties of, that is, solids. it is possible to prepare the solid materials which are having desired properties. Okay. So first let us study about the general characteristics of solids. General characteristics of solids. As I already said, matter exists in three different states: solids, liquids and gases. See, under a given set of temperature and pressure, which state of matter it is more stable for a given substance. For example, if you take water, water is the naturally occurring substance. It is the only naturally occurring substance which exists in all the three physical states. In the form of solid, water exists as ice. Similarly, over large range of temperature, it exists as liquid water. Similarly, in atmosphere, water vapor is present, which is gaseous form of water. So under a given set of temperature and pressure, which is the most stable state for a given substance? That is the question. See, that depends on the net effect of two opposing factors. One is thermal energy, and second is intermolecular forces. So thermal energy, it always tend to keep molecules away from one another, whereas intermolecular forces, they always try to bind the particles. So the net effect between thermal energy and intermolecular forces, it actually results in, that is, three different states of matter. For example, you know that matter can be converted from one state to another state. Interconversion of states of matter you are familiar. Solid can be converted into liquid, and liquid can be converted into gas. How we can convert solid into liquid or liquid into gas? It is by supplying heat. When solid is heated, it changes into liquid state. Similarly, when liquid is heated, it changes into gaseous state. For example, ice. Ice changes into liquid water when ice is kept exposed to air. That means at room temperature, solid form of ice changes into liquid state. Okay. So water can exist in the form of ice only at 0 degrees Celsius. But when ice is kept exposed to room temperature, temperature rises. That means heat is supplied, and as a result, that is, solid form of ice changes into liquid water. Similarly, if you boil liquid water, it changes into steam, which is gaseous form of water. So, in general, solid is converted into liquid, liquid is converted into gas by supplying heat. Similarly, by removing heat, it is possible to convert gas into liquid, that is by decreasing temperature. So, steam on cooling changes into droplets of water, liquid water. Similarly, Similarly, when liquid water is kept in freezer, liquid water changes into ice. So in general, by removing heat, we can convert, that is, gaseous form into liquid form into solid form. Okay. So by increasing or decreasing temperature, it is possible to convert one form of matter into another form. Similarly, pressure. By increasing or decreasing pressure, it is possible to convert one state of matter into another state. See, when temperature increases, what happens? Thermal energy increases. Similarly, when temperature is decreased, thermal energy decreases. So when thermal energy increases, intermolecular force of attraction decreases. So if you take solid state, intermolecular forces are strong, whereas if you take gases, intermolecular forces are weak. Okay, so that means, that is, thermal energy and intermolecular forces, the net effect, it is actually responsible for the existence of a substance either in the form of solid state, liquid state or gaseous state. See, at low temperature, thermal energy will be less, and once thermal energy is less, so at low temperature, thermal energy will be less, and as a result, intermolecular forces will be strong. And due to strong intermolecular forces, molecules, they come closer and they cling to one another. So that means they occupy fixed positions. So in a substance at low temperature, due to less thermal energy, intermolecular forces become stronger, and as a result, molecules come closer and they cling to one another. They occupy fixed positions. Even though they occupy fixed positions, they will be vibrating about their mean positions. Okay, so molecules of matter, they are in constant motion, whether it is in solid state or liquid state or in gaseous state. Particles will be moving. See, in case of solid state, movement is restricted to vibration. So they occupy fixed positions, and in that position itself, particles will be vibrating about their mean position, and which results in the existence of matter in solid state. So when actually you can expect a substance to exist in solid state at low temperature due to less thermal energy, intermolecular forces become stronger, and due to that strong intermolecular forces, molecules, they cling to one another and they occupy fixed positions, and which results in the existence of that substance in solid state. Okay, so this is how we can explain the existence of matter in solid state. So matter is existing in solid state mainly because of the net effect of two opposing forces. One is thermal energy and another is intermolecular forces. And because of that, solids, they exhibit certain general characteristic properties. So properties of solids are different from properties of liquids and gases. So reason for difference in properties of states of matter, it is mainly because of the arrangement of constituent particles, and that arrangement of constituent particles, it is the net effect of two opposing forces, that is thermal energy and intermolecular forces. So let us recall some of the important general characteristic properties of solids. Okay, first is solids, they have definite shape, volume. Solids have definite shape, volume and mass. Okay. Whereas if you take liquids and gases, they actually take the shape of the container, whereas solids have definite shape. And similarly, volume. Liquids do not have definite, that means liquids have definite volume, but if you take gases, they do not have definite volume. Volume is nothing but space occupied by a substance is nothing but volume. And similarly, mass. So solids, they have definite shape, volume and mass. All the three states of matter, they have definite mass. Muru states of matter ige mass definite ಆಗಿರುತ್ತೆ. ಆದರೆ ವಾಲ್ಯೂಮ್ ಅಂತ ತಗೊಂಡಾಗ ಸಾಲಿಡ್ಸ್ ಮತ್ತೆ ಲಿಕ್ವಿಡ್ಸ್ ಗೆ ಡೆಫಿನೆಟ್ ವಾಲ್ಯೂಮ್ ಇರುತ್ತೆ, ಗ್ಯಾಸಸ್ ಗೆ ಡೆಫಿನೆಟ್ ವಾಲ್ಯೂಮ್ ಇರೋದಿಲ್ಲ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಇಫ್ ಯು ಟೇಕ್ 100 grams of a gas, that can be filled in a small cylinder. Same 100 grams of gas, it can be filled in a room. Okay, 100 grams of gas ಅನ್ನು ತಗೊಂಡಾಗ ಒಂದು ಸ್ಮಾಲ್ ಸಿಲಿಂಡರ್ ತಗೊಂಡ್ರೆ ಆ ಸಿಲಿಂಡರ್ ಅಲ್ಲಿ ಏನು ಸ್ಪೇಸ್ ಇರುತ್ತೆ ಅಷ್ಟು ಸ್ಪೇಸ್ ಅನ್ನು ಆಕ್ಯುಪೈ ಮಾಡ್ಕೊಳ್ಳುತ್ತೆ. ಸೇಮ್ 100 grams of gas, when you fill in a say a big room, that 100 grams of gas, it occupies the entire space which is available. That's why gases do not have definite volume, whereas solids and liquids, they have definite volume. And when you come to shape, solids have definite shape, but liquids and gases, they do not have definite shape. They takes the shape of the container. So if question is asked why solids have definite shape, the reason is arrangement of constituent particles. So in solids, particles, they occupy fixed positions. They will not move. Movement will be there, but that movement, it is termed as vibration. In the fixed position itself, particles will be vibrating about their mean position. But if you take liquid or a gas, particles can move from one place to another place. That's why liquids and gases are called as fluids anta ಹೇಳ್ತಾರೆ. liquids ಮತ್ತೆ gases ಅನ್ನ fluids ಅಂತ ಹೇಳ್ತೀವಿ. Solids are rigid. Okay, so that is the reason why solids have definite shape. So first characteristic property. Then second is intermolecular forces are strong in solids. That is mainly because of distance. So intermolecular forces are strong due to that is less intermolecular distance. So distance between particles will be less, and as a result, intermolecular forces are strong. So reason is thermal energy. Okay, so in solids, thermal energy will be very less, and because of less thermal energy, that is kinetic energy associated with particles of solids will be less, and as a result intermolecular distances will be less, which results in strong intermolecular forces. The next is so particles occupy fixed positions, and in that position itself they will be vibrating about their, that is, mean positions. In that position itself there will be, that is, movement of particles, and that movement of particles is known as vibration. Okay, and then incompressible incompressible and rigid. So solids cannot be compressed, whereas liquids and gases can be compressed. And similarly, solids are rigid. So reason why they are incompressible, because if you observe the position of particles in solids, particles are very compactly arranged, and as a result intermolecular distances are very less. You cannot compress. Whereas if you take liquids and gases, intermolecular distances are more, and as a result, that is, particles can be made to come closer. So as a result, they can be compressed. And similarly rigid, since in solids particles occupy fixed positions, that is, they will not move from one place to another place. Whereas gases and liquids, they are fluids. That means they can move from one place to another place. Okay. So these are the general characteristics of, that is, solids. Next we will discuss, that is, classification of solids. Classification of solids. Okay. See, solids, they are classified into two types depending upon the nature of order. Very important. Based on the nature of order, solids are classified into two types. One is crystalline solids and another is amorphous solids. So based on the nature of order, solids are classified into two types: crystalline solids and amorphous solids. For example, NaCl, common salt, sodium chloride is an example for crystalline solid. Similarly, quartz, which is SiO2, is an example for crystalline solid. Diamond, graphite, silicon carbide, then calcium fluoride. They are all examples for crystalline solids. Similarly, metallic elements, that is copper, silver, gold, magnesium, zinc, metallic elements, they are also examples for crystalline solids. Similarly, non-metallic elements like sulfur, phosphorus, diamond, graphite, which are allotropic forms of carbon, they are also examples for, that is, crystalline solids. So, metallic elements, many non-metallic elements, and many compounds, they are all examples for crystalline solids. Whereas if you take amorphous solids, examples for amorphous solids, glass is an example for amorphous solid. Plastics, they are example for amorphous solids. Similarly, wood is an example for amorphous solid. Okay, so glass, plastics, then wood, they are all examples for amorphous solids. So what is the basis that is used to say whether a solid is crystalline solid or amorphous solid? It is the nature of order. Okay, so in crystalline solids, order is long range order. So crystalline solids, they have long range order, whereas amorphous solids, they have short range order. Okay, see, based on the difference in the nature of order, solids are classified into two types: crystalline solids and amorphous solids. In crystalline solids, that is, order is long range order, whereas in amorphous solids, the order is short range order. So question is, what is long range order and what is short range order? See, if you take crystalline solids, the constituent particles will be arranged in a particular order which gives a definite geometrical shape. So due to ordered arrangement of constituent particles, crystalline solids, they have a definite geometrical shape, and that definite geometrical shape, it exists over the entire crystal. So that means long range order means, that is, the arrangement of particles in a repeated way over the entire crystal. So regular periodical repetition of arrangement of particles throughout the entire crystal, it is known as long range order, and which gives a definite geometrical shape. Whereas if you take amorphous solids, they are irregular in shape. That means constituent particles arrangement, it is not, that is, in an orderly way. Or if it is there, that orderly arrangement of constituent particles, it is only for short range. Okay? In general, in amorphous solids, there is no ordered arrangement of constituent particles, and as a result, they have irregular shape. Suppose if you find that is ordered arrangement in amorphous solids, it is only for short range, and as a result, they get irregular shape. So in crystalline solids, long range order is present, which is nothing but that is regular periodic repetition of arrangement of particles throughout the crystal, ordered arrangement of particles over the entire crystal. Okay? Whereas in case of amorphous solids, that regular periodic arrangement of constituent particles, it is only for short distances or it is only for short range. So as a result, that is crystalline solids, they have definite geometrical shape, whereas amorphous solids, they are irregular in shape. So the main difference between crystalline solids and amorphous solids is nature of order. Long range order crystalline solids, short range order for amorphous solids. And in addition to this, that is, we can also see other differences between crystalline solids and amorphous solids. So let us discuss what are the differences between crystalline solids and amorphous solids apart from the nature of order. Okay, we'll continue.